Considering electrical solutions for a condo project divided into modules, where each module, consisting of 3 units, is separated by block walls and served by a meter pack, presents unique challenges for common lighting. The goal is to power common garages, hallways, and exterior wall-mounted lights efficiently. The National Electrical Code, NEC, requires careful consideration in these scenarios. Firstly, one option involves installing individual house panels for each module. Technically, this adheres to the building served by one service rule. However, this approach can be more expensive due to the increased number of panels, associated wiring, and installation labor. It also leads to more complex maintenance and troubleshooting because the common lighting circuits are distributed across multiple locations. Secondly, a single main breaker service entrance switch, SES, with meter packs offers a more streamlined and frequently used solution. This approach consolidates the common lighting circuit into one central location, reducing costs and simplifying maintenance. Here's a detailed breakdown of how to implement this solution. 1. Install a single main breaker service entrance switch at the point where the electrical service enters the entire building. This SES serves as the main disconnect for all meter packs in the common lighting system, providing a central control point for the entire electrical system. 2. Inside the SES, install a main breaker panel. This panel houses the main breaker that protects the entire building's electrical system. The main breaker acts as the main overcurrent device, OCT, for the common lighting circuit. This setup provides a single point of protection and disconnection for the common lighting, enhancing safety and simplifying troubleshooting. 3. Connect each module's meter pack to the main breaker panel through a subfeed. A subfeed is a circuit that branches off from the main panel to supply power to a specific load, in this case, the meter pack for each module. The subfeed circuit must be protected by a sub-panel breaker located within the main breaker panel. This ensures that each module's meter pack is individually protected, preventing overloads and short circuits from affecting the entire system. 4. Run a dedicated circuit from the main breaker panel to all the common lighting fixtures. This circuit should be protected by its own circuit breaker within the main breaker panel, sized appropriately for the load of the lighting fixtures. Using a separate circuit ensures that the common lighting is isolated from the individual unit circuits, preventing any issues in the units from affecting the common lighting. Some additional considerations that are important include the use of appropriate conduit. Use rigid metal conduit, RMC, or flexible metal conduit, FMC, to run the subfeeds from the main breaker panel to the meter packs. RMC provides excellent physical protection and is suitable for both indoor and outdoor applications. FMC offers flexibility for navigating tight spaces and is suitable for dry, indoor locations. Always follow the NEC guidelines for conduit fill and support. Grounding is also critical for safety. Ensure that all electrical components, including the SES, main breaker panel, meter packs, and lighting fixtures, are properly grounded in accordance with the National Electrical Code, NEC. Proper grounding provides a low impedance path for fault current, reducing the risk of electrical shock and equipment damage. Grounding should comply with NEC Article 250. Fire stopping is a code requirement. When running conduits or cables through block walls or framed exterior walls, seal any penetrations with fire-rated sealant to maintain the fire resistance rating of the building. This prevents the spread of fire and smoke from one area to another. Fire stopping should comply with local building codes and NEC section 300.21. Now considering the advantages of the single main breaker SES with meter packs. Firstly, it reduces the overall cost and complexity compared to individual house panels. By consolidating the common lighting circuit into a single panel, you reduce the amount of wiring, conduit, and equipment needed. This also simplifies the installation process, saving time and labor costs. Secondly, the centralized control and protection of all electrical systems improves safety and convenience. With all the common lighting circuits originating from a single panel, it's easier to monitor and control the system. This also makes it easier to disconnect the power to the common lighting for maintenance or repairs. Thirdly, easier maintenance and troubleshooting result from this setup. Having all the common lighting circuits in one location simplifies troubleshooting. If there's a problem with the lighting, you can quickly identify and resolve the issue from the main breaker panel, minimizing downtime and inconvenience. When selecting the appropriate size of the main breaker and sub-panel breakers, the calculations must be precise and adhere to NEC guidelines. For the main breaker, determine the total connected load of all the meter packs and the common lighting circuit. Add up the amperage requirements of each unit and the common lighting. Size the main breaker to be at least this value, but no less than the calculated load. For the sub-panel breakers, calculate the load for each meter pack based on the unit's electrical requirements. Size the sub-panel breakers to protect the sub-feed circuit in the meter pack. Refer to NEC Table 310.15. B16 for ampacity ratings of conductors. The common lighting circuit breaker should be sized according to the total wattage of the lighting fixtures. Divide the total wattage by the voltage of the circuit, typically 120 volts or 277 volts, to determine the amperage. Select a breaker that is rated for at least this amperage. Also, consider any potential future expansion when sizing the breakers and panels. Leave some spare capacity in the main breaker panel to accommodate any future additions to the electrical system. This could include adding more lighting fixtures, installing new equipment, or expanding the building's electrical service. Additionally, it's important to coordinate with the local utility company to ensure that the service entrance equipment meets their requirements. The utility company may have specific standards for the size and type of service entrance equipment, as well as the location of the meter packs. It's also essential to obtain all necessary permits and inspections from the local building department. The electrical work must comply with all applicable codes and regulations. A licensed electrical contractor should be consulted and hired to ensure that the installation is done safely and correctly. Now considering the conduit selection, using rigid metal conduit, RMC, or intermediate metal conduit, IMC, provides the best physical protection for the conductors. These types of conduit are suitable for both indoor and outdoor applications and can withstand physical damage from impacts and environmental factors. Flexible metal conduit, FMC, can be used in certain situations where flexibility is needed, such as connecting to motors or other equipment that vibrates. However, FMC is not suitable for wet locations or for direct burial. Electrical metallic tubing (EMT) is a lightweight conduit that is suitable for indoor applications. EMT is easy to install and can be bent to fit around obstacles. However, EMT is not as strong as RNC or INC and is not suitable for outdoor applications. When installing conduit, follow the NEC guidelines for conduit fill. The number of conductors that can be installed in a conduit is limited by the size of the conduit and the size of the conductors. Overfilling a conduit can cause overheating and damage to the conductors. Now considering the grounding and bonding, the grounding electrode system should be installed in accordance with NEC Article 250. This system consists of a grounding electrode, such as a ground rod or a metal water pipe, that is connected to the electrical system. The grounding electrode provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This includes bonding the metal conduit, the metal enclosures, and the metal equipment. Bonding ensures that all metal parts are at the same potential, reducing the risk of electrical shock. When making connections, use approved connectors and fittings that are listed for the specific application. These connectors should be properly tightened to ensure a secure connection. Avoid using wire nuts for grounding connections. Instead, use grounding lugs or other approved grounding connectors. The overcurrent protection should consist of circuit breakers or fuses that are sized to protect the conductors. The overcurrent protection should be located at the point where the conductors receive their supply. Circuit breakers are more commonly used than fuses because they can be reset after they trip. Fuses must be replaced after they blow. The circuit breaker should be properly labeled to indicate the circuit that they protect. The label should be clear and easy to read. The wiring methods should comply with NEC Chapter 3. The wiring methods include the type of conductors, the type of insulation, and the method of installation. The conductors should be sized appropriately for the load that they will carry. The insulation should be rated for the voltage and temperature of the circuit. The wiring should be installed in a neat and workmanlike manner. When installing wiring in walls or ceilings, protect the wiring from physical damage by using nail plates or other protective devices. When running wiring through holes in wood framing members, the holes should be located at least 1/4 inches from the edge of the framing member. This prevents the wiring from being damaged by nails or screws. The common lighting system should be controlled by switches that are located in convenient locations. The switches should be clearly labeled to indicate the lights that they control. The common lighting system should also be equipped with a timer or a photocell to automatically turn the lights on and off. A timer can be used to turn the lights on and off at specific times of the day. A photocell can be used to turn the lights on when it gets dark and off when it gets light. The maintenance of the common lighting system should include regular inspections to ensure that the system is operating properly. The inspection should include checking the lights to make sure they are working, checking the switches to make sure they are operating properly, and checking the wiring to make sure it is in good condition. Any problems that are found should be corrected promptly. In addition to the above considerations, it is also important to consider the energy efficiency of the common lighting system. Use energy-efficient lighting fixtures such as LED fixtures. LED fixtures use significantly less energy than traditional incandescent fixtures, which saves money on electricity bills. Install occupancy sensors to automatically turn off the lights when no one is present. Occupancy sensors can save a significant amount of energy by turning off the lights in unoccupied areas. Use dimming controls to adjust the brightness of the lights. Dimming controls can save energy by reducing the amount of light that is used when full brightness is not needed. Consider the aesthetics of the common lighting system. The lighting fixtures should be aesthetically pleasing and should complement the architecture of the building. The lighting should provide adequate illumination without being too bright or too dim. The lighting should also be designed to minimize glare and shadows. Consult with a lighting designer to help design the common lighting system. A lighting designer can help select the appropriate lighting fixtures, locate the fixtures in the best locations, and design the lighting controls. Always consult with a qualified electrical contractor to ensure that the common lighting system is installed safely and in accordance with all applicable codes and regulations. Remember that safety should be the top priority when installing and maintaining electrical systems. By following these guidelines, you can ensure that the common lighting system is safe, efficient, and aesthetically pleasing. Remember that local codes and regulations may vary, so it is always best to consult with a qualified professional to ensure compliance. In summary, while individual house panels are a technically compliant option, a single main breaker SAS with meter packs offers a more practical and cost-effective solution for common lighting in modular condo projects. By carefully considering the installation, grounding, fire stopping, and maintenance aspects, you can create a safe, efficient, and reliable electrical system that meets the needs of the residents in the building. The NEC provides a comprehensive set of guidelines for electrical installations. Adhering to these guidelines ensures the safety and reliability of the electrical system. Staying up to date on the latest NEC requirements and best practices is essential for electrical professionals.